Good morning, one and all. So, in this lecture video, I'm going to start with the third unit in artificial intelligence. So, let me move on to the topic of third unit, that is planning with state space search. So, in this, we are going to see about what is forward state space search algorithm, that means progression, and what is backward state space search algorithm, that is regression. These are the two types of search. This search algorithm is a straightforward approach of planning algorithm in state space search. So, why? Because the description of actions in a planning problem which specify both preconditions and effects. So, the search is possible in both the directions, that is forward and backward. Here we can see the example of forward and backward search, which we have seen in the previous video, how the forward search will be and how the backward search will be. It will start with the initial state, and backward will start with the final state. So that's what forward means. Progression state space progression means forward state space search, which is starting in the initial state and end with the goal state, whereas backward is it will start in the goal state and end in the initial state. So first we move on to forward state space search. The definition goes here like this. We are planning with forward state space search, which is similar to the general or the traditional problem solving approach, which is also called as progress planning. So as I said before, it will start with the problem's initial state, continuous sequence of actions will be there, and it will finally reach the goal state. The formula of planning problem as state space search algorithm is as follows. We'll start with the initial state of the search from the planning problem. Each state will be a set of positive ground literals and literals not appearing or false. The successor state resulting from an action is generated by adding the positive effect. So it will start with the initial goal, initial state. Sequence of actions will be performed, followed by the goal state. And we need to consider the cost of each action too. So here is a better example of understanding the forward state space. You have an air cargo problem with the 10 airports, where each airport will have 5 planes and 20 pieces of cargoes are there. So the goal is to move all the cargo at airport A to airport B. There is a simple solution to the problem is that we can load the 20 pieces of cargo into one of the plane called A, and then we can fly the plane to B, and we can unload the cargo. But if we do like this, it can be a difficult one, since we have a branching problem here. The depth will be huge. Here each of the 50 planes can fly to 9 other airports, and each of the 200 packages can be either unloaded. So this is the problem arise here. So on an average, let me say, like, there are 1,000 possible actions. So the search tree up to the depth will be obvious solution, which has around 1,000 nodes. So it is shown clearly that this forward search algorithm is not an efficient one. We better move for our betterment, we can move for the heuristic kind of search. So let me continue with the next video to proceed for the solution, to find the solution for this particular problem. Thank you. So here in the next video, we are going to see about the backward state space search algorithm. So what is backward is, as we saw earlier, backward search is nothing but we should start from the goal state and we need to do the sequence of actions in the reverse order, and we have to combine the solution, and we need to reach the uh, initial state. So which is, that's just an inverse of the forward search state space algorithm. So as we saw, like forward state space search is a progression planning. Here backward is called as the regression, which we saw in the initial definition while seeing the definition. I mean, the first slide of the definition.